Welcome to the Pre-Med Preacher. Today we're doing an exam review for Physics 250, so we'll get right into it. Hope you guys enjoy. For question 16, you're going to want to draw a free body diagram. You have the skater who's jumping, and she's experiencing the force of gravity while she's coming down on the ice. The ice is also exerting a force up on her. Now let's remember Newton's second law. The net force equals the mass times the acceleration. In this case, the mass of the figure skater is 50 kilograms. But what's her acceleration? Well, in the problem, they tell us that she experiences a deceleration of 25 meters per second. However, when she's coming down, the force of gravity is also acting on her. So we have to add 9.8 meters per second squared additionally onto her original 25 meter per second deceleration for a total acceleration of 34.8 meters per second squared. And when we do this, we find that the force is equal to 1,740 newtons. Problem 17 is a third kinematics problem, where we're given that the acceleration on the planet of Venus is equal to 8.87 meters per second squared. We know that the height of the ball that we threw is equal to 35 meters, and we also know that the final velocity in the y direction has to be equal to 0 when it reaches its peak. Let's draw a picture. Now, we're looking for the initial in the y direction. So what kinematics equation can help us solve this? Well, if we plug into the following equation, we'll find that v initial squared plus 2 times the acceleration on the planet times delta h, which we know is 35. We can set that equal to 0, which is v final squared. If we solve using algebra, we'll find that the initial speed in the y direction that the astronaut threw the ball was 24.9 meters per second squared. Meters per second. Questions 18 through 20 deal with a velocity versus time graph. Question 18 asks, what's the velocity at 6 seconds? Because it's a velocity versus time graph, we can simply follow the graph and go to 6 seconds and track it up to find that the velocity is 0 meters per second at a time of 6 seconds. For a velocity versus time graph, to find displacement, we need to find the area between 0 seconds and 10 seconds under the curve of a velocity versus time graph. So we're going to break the graph into triangles and squares. If we then sum up the area above the curve and subtract out the area below the curve, we should find our displacement between 0 and 10 seconds for this graph. So we have 1/2 times 4 times 2 plus 1/2 times 2 times 2 minus 4 minus 2, which gives us a net displacement of 0 meters, or answer choice C. Question 20 asks, what is the acceleration at 5 seconds? If you look at your equation sheet, you'll realize that the slope of a displacement versus time graph is equal to the velocity, and the slope of a velocity versus time graph is equal to the acceleration. So since this is a velocity versus time graph, the slope of this graph will tell us what the acceleration is at 5 seconds. So we can choose 2 points around 5 seconds and calculate the slope in order to find the acceleration. So we'll choose the coordinate 4, 2 and the coordinate 6, 0. Given that, we're going to calculate the rise over the run, or the delta y over the delta x. The change in y was down 2, and the change in x was up 2. Therefore, our acceleration is negative 1 meters per second squared. Or answer choice A.
Familiar.